Okay, I'd like to go through some of these particular problems that were in the notes and just kind of go through them and make sure you can kind of understand what we're getting at. There's 4 of them I'd like to do right away. This first one right here, you know, when you get the hang of it, you won't need to do this, but the inside amount right here, cosine inverse negative radical 3 over 2. So what I would ask you to do is understand that you're being asked for an angle measurement, right? This is asking for an angle given an x value. All right, so the x value is negative radical 3 over 2, and we want to know the angle. So here's negative a half, right? And negative radical 2 over 2, and then negative radical 3 over 2 all the way out on the outside edge. And so the top half of the circle would be telling me 5 pi over 6, right? When we think about the angle measurements. And so now this question is asking for the cosine, that would be the x value, at 5 pi over 6. Well, the x value at 5 pi over 6 is, just as we had figured out, negative radical 3 over 2. Okay? So anyway, that's the first question I wanted to do. Then I wanted to jump down in the middle here to this question right here, sine inverse of 1/2. So this is also looking for an angle measurement with a y value of 1/2. So if you think about the circle, see if I can draw a halfway decent circle. The y value is 1/2, and you have to give me an answer that's inside the range of the inverse sine function, so that would be over here, and so this angle measurement would be pi over 6. So right inside there is pi over 6. Now right here this is asking for the y value at pi over 6. Well, the y value at pi over 6, that's 1/2. Okay, let's move over a little bit right here to this question right here, second one from the bottom. We've got tangent of tangent inverse of -1. So the slope, I need an angle measurement, right? They want an angle for a slope of -1. Angle measurement for a slope of -1. Well, on the circle, for the inverse tangent function, that would be the right half. That would be right here. The slope is -1 at negative pi over 4. So this part in the middle would be negative pi over 4. Remember how we talked about in class, you can't call it 7 pi over 4 because the inverse tangent function only has a range from negative pi over 2 to pi over 2, not including the endpoints. 7 pi over 4 wouldn't be in that range. But this question is asking for the slope at negative pi over 4. Well, what's the slope at negative pi over 4? Well, that's -1. Then the third one here from the top, tangent inverse. Let's see, so I want the angle measurement where the slope is radical 3 over 3. Okay, so let's think about the unit circle here. Slope is positive radical 3 over 3. That's the shallow one, right, in quadrant 1. That would have to be pi over 6, the shallow angle measurement. What's the slope at pi over 6? That's what this is saying. What's the slope at pi over 6? And that slope at pi over 6 is radical 3 over 3. Now, these 4 questions that I have done with you are different than the rest of the questions on this page. Because these 4 questions right here all start off with a trig function. And it is always true that when the trig function's on the outside and the inverse trig function's on the inside, they will always cancel out. Unless, of course, they're different trig functions. Okay, we could end up mixing a cosine and a sine or something like that, but not for these questions here. I'm just practicing with you. All right, so let's take a look at these other questions and how they're different. The cosine of 210 degrees. Well, the cosine at 210 is down here in quadrant 3. The cosine is negative radical 3 over 2. Okay, so we are being asked for the cosine inverse. That's an angle measurement. Inside the range, right? The range for the inverse cosine is from 0 to pi, the top half of the circle. And so your answers have to be up here. And it has to have the same angle measurement as something that has an x value at negative radical 3 over 2. Well, that's right here. Now, I'm not going to use radian measure because they started with a degree measure. So what do I call that? I don't call it 5 pi over 6. I call it 150 degrees. Okay? 5 pi over 3, that's sitting right here, 5 pi over 3. The cosine of 5 pi over 3 looks like 1/2. And the cosine inverse at 1/2, that's going to take me to the top half of the circle, would be right about there. That is pi over 3. Cosine negative pi over 6. Negative pi over 6 is right here. And the cosine of that is positive radical 3 over 2. So cosine inverse is looking for an angle measurement in the top half of the circle with the exact same x value. If I go up, I'll get to that one right there, which is positive pi over 6. 3 pi over 4, that's right over here. 3 pi over 4. If I can draw it right. The cosine for 3 pi over 4 is negative radical 2 over 2. What's the cosine inverse of that? The cosine inverse is looking for an angle measurement in the top half of the circle that has an x value at negative radical 2 over 2. And the x value, negative radical 2 over 2, in the top half of the circle would have to be the same thing, 3 pi over 4. Now, I know some of you are going to say, well, look, they canceled out. Well, that's true because you started with an angle measurement that was already in the top half of the circle. If you start with something that's up the top half of the circle, you're going to stay in the top half of the circle. These other ones you gave me were 5 pi over 3, sent me to the top half of the circle. Negative pi over 6, 210 degrees. All of them sent me to the top half of the circle. If you start in the top half, you'll stay there. Okay? Negative 270. Negative 270 is here. Okay? And if we kind of use that same logic, the cosine at negative 270 is 0. And so what's the cosine inverse of 0? Cosine inverse of 0 is in the top half of the circle is pi over 2. Do we want to call it pi over 2? No, we probably want to call it 90 degrees since we're dealing with degrees. Cosine at 2 pi over 3. Okay. Let's see here. 2 pi over 3 is right about here. Cosine of that is 1/2, or negative 1/2. And the cosine inverse of negative 1/2 is 2 pi over 3. See, they canceled out. Because we started with an angle measurement already in the top half. Guess what? Starting with an angle measurement in the top half, pi over 4. Negative 5 pi over 3. Negative 5 pi over 3 is the last one here. Negative 5 pi over 3, that would be all the way around here. Now I know we're in the top half of the circle, but the answer is not going to be negative 5 pi over 3. Alright, so for instance, the cosine of negative 5 pi over 3 is 1/2. And the cosine inverse of 1/2 is an angle measurement between 0 and pi. Have to be this one right here. We'll call it pi over 3. So that's the final answer on that one right there is pi over 3. Switching gears to sine inverse. So let's say we deal with 150 degrees is over here. Sine inverse is not going to send me to the top half of the circle. It's going to send me to the right half from negative pi over 2 to positive pi over 2. So sending me to the right half of the circle is over here. And so this one right here is going to end up being 30 degrees. Negative 7 pi over 6 is the same location, right, going in the negative direction. Negative 6 pi over 6, negative 7 pi over 6. And remember, it's going to shove me over to the right half of the circle, right, because you're going to find the y value first, and then you're going to find the angle measurement over here, and it has to be the same, have the same y value, so the answer is going to be 1 pi over 6. I know I'm kind of moving quicker through this, but I hope you're getting the idea. Pi over 3, right? Pi over 3 is up here. It's already in the range of the inverse sine function, so I'm pretty much guessing that these are going to cancel out because the y value is radical 3 over 2, and then sine inverse is going to take you right back to that spot, so pi over 3. So they indeed did cancel out, only because you started with an angle inside of the range of the inverse sine function. Okay, so 7 pi over 4, that's down here, because you went around all the way down to 7 pi over 4. Now, I know that we are technically on the right half of the circle, but you can't call it 7 pi over 4, because it's not, 7 pi over 4 is not in the range of the inverse sine, so you must call it negative pi over 4 to find some angle measurement that has the same y value as 7 pi over 4. So I need an angle measurement that has the same y value as negative 5 pi over 6, and you're only allowed to choose values on the right half of the circle. Negative 5 pi over 6 is right about here, and so I would be looking at negative pi over 6. Negative pi over 6. The angle measurement that has the same y value as 5 pi over 6, 5 pi over 6 is here. Okay, this is exactly the same as the first question about the 150 degrees. It's going to take me across to 1 pi over 6. And a couple more here that they have listed out. 4 pi over 3 is here, and you are being sent to the right half of the circle, but you can't call it what you think maybe. It is negative 1 pi over 3. Negative pi over 4 is already in the range of the inverse sine, so it's going to stay negative pi over 4. The two will cancel out. In terms of tangents, remember the tangent function, so I need something with an angle measurement between negative pi over 2 to pi over 2, or in this case negative 90 to 90. Not including the endpoints, that has the same y value as 300. Well, if you look at the unit circle and think in terms of 300 degrees, 90, 180, 270, so we're talking down here for 300. So something that has the exact same slope, and you can only choose values from negative 90 to 90, would be negative 60. Negative 60 degrees, because that's down here. Negative pi over 3, that is in the range of the inverse tangent, and so these are going to end up canceling out. Negative 4 pi over 3, okay, so it's negative 1, negative 2, negative 3. Negative 4 pi over 3 sits here. Remember, since we're dealing with slopes, you are following the slope, not the x value or the y value, but you're following the slope of the line. So the answer is still negative pi over 3, because it's throwing you down through the origin. Okay, negative 11 pi over 6. Negative 11 pi over 6 is coming around to right about there. It looks like the similar spot inside the range of the inverse tangent, and hopefully you know that better as 1 pi over 6. Seven pi over 6 is down here. Looking for something on this side of the circle which has the same slope. Once again, sending me through the origin, right? Finding the same slope, so the answer is 1 pi over 6. The tangent of pi over 2. Oh, tangent of pi over 2, that's undefined. So we're looking for an angle measurement that has an undefined slope inside the range of the inverse tangent function. None such value exists. Okay, there's no value inside the range of the inverse tangent at the endpoints pi over 2 and negative pi over 2. So kind of a trick question. 5 pi over 4, the last one here on the list. Come back up here to my circle. 5 pi over 4. Got 1, 2, 3, 4. 5 pi over 4 is here. Going through the origin will land me at 1 pi over 4. Okay. So that's just a review of all those problems. We need to get good at practicing those questions as well. So now I can do the 5-7 video.